Is this a good one to start with? Do people struggle with this one? Or were most people good? I struggle.
I got it right!
Right. Alright, I didn't even know.
Probably.
Right, okay, so we've got a circle. We've got some markings on there. As I said, it's not drawn accurately, so you need to remember that. We do spot, however, that we've got these two lines here, which means that what? Yeah, those lengths are equal. Okay? Now, I can see that this here then must be what kind of triangle? Isosceles. Great. So if I know that this angle here is x, I can label this one here as x. Yes? Right, maybe I should actually see what we're trying to do. We are trying to find the value of x. Alright, what's that? What else do we know here? Tanya?
69 plus y plus x equals 180.
Oh, so you've labelled this bad boy y, have you?
I just didn't
Any other, Hannah?
That it's the exterior angle of like C, that is 2x, because it's double the interior one.
This bit here. Okay, so Hannah's suggesting that this one here would be 2x. Now, are we happy with that?
Yeah.
I'm not ignoring yours, Miss Tanya. I'm just trying to avoid writing other letters. So, here's our triangle. Here's our line that extends that. This is the exterior angle of our triangle. It's equal to the sum of the two interior opposites. Okay, that's one of those angle reasons that were on that sheet. So, when any triangle, the exterior angle is equal to the sum of the two interior angles opposite.
Opposite?
Essentially, the two angles that are not attached to it. That makes sense. The reason being is because we know that these two angles add up to 180. We know that these three angles add up to 180, which must mean that this one is equal to these two.
Yeah.
That makes sense?
Yeah.
What else do you know? Aria? Do you want to show? I'll make your participation where possible. Yeah, why? Yeah, explain why. Yeah. Now, did everyone hear that? So this angle here can also be labelled as 2x, because these two lines here, whilst they're not labelled, they both come from the centre, don't they? Yes? So that means that these two lengths must be equal, which means that these two angles are also equal, because that's another isosceles. We?
They're equal because they both come from the center of the circle.
Is that a question or a statement?
A question.
Yes. Because they are both really are.
Oh! Okay.
So when you do that, you have 2x plus x plus 1x and
Tell me again.
this is a triangle. So
Which triangle are we talking about? Sorry.
the giant one.
This giant one here.
Yeah.
Roger that.
So if you do 180 minus 69, which will give you that angle on the other side of 69, like this is plus 3x and 3.
Yes, totally. I mean, when it comes to these kinds of things, there are slightly different ways of doing them. Okay? I'm going with one option just from what people are saying here. So, Emily's suggestion is that this baby here is a big triangle, yes? We're just ignoring that middle line through it. We know that this angle here is 2x. We know this one here is x. We can find this one because we know that this one and this one add up to 180, yes? So we can find this big one by doing 180 subtract 69 with that. Okay? Which means that this value plus this 111 have to add up to give 180. Yes, because they're the three angles in a triangle. If you did it differently, please do not think, oh my god, I did it wrong. You didn't, there are different ways of doing this. So we could say that 2x plus x plus 111 is 180, or yes, you can say that 2x plus x is 6. Alright, because this line here comes from the centre, and this one here also comes from the centre, it means that that is an isosceles triangle. Check it now. Are we trusting answer? So 2x plus x is 3x is equal to 69. Again, we could have just done external angle for triangle, couldn't we? So x is 69 over 3, which is good. Oh, and pause. Show that question. People often don't like, and the reason being is that they're unlikely to have met something the same as it in the past. You always need to use the information they've given you. So they've told you that the area of a trapezium is 60 centimetres squared. That's our key thing here. We know the value of the area of the trapezium. It's best to ignore this for now. Okay, so just ignore it for now. What you're going to do is you're going to set yourself up an equation knowing that the area of the trapezium is equal to 60. Once you've done that, you're going to then rearrange it, and you rearrange it, and hopefully you end up with 3x squared plus 10x minus 176. Now, some of you who started off okay may have made a minor error and still managed to fudge it so that you did end up with that. And like your perseverance, yes, at attempt, great. And if the person marks it with too much attention, you might get away with it. But let's assume that they will be paying attention, so you won't. Right, so area of a trapezium. Who's got their formula? Anyone? No, but do you get given it? I can't remember. I know you used to. Alright, okay, so it's A plus B over 2 multiplied by H. And that is from this being H, this is A, and this is B. Okay, so you're going to add your two A and B, your A and your B, divide that by 2, and then you're going to multiply it by the perpendicular distance between them. So our A is 2x minus 4. You're going to add B, which in our case is x plus 5. We're going to divide that by 2, and we're going to multiply that by x plus 3. Now notice brackets are super important when it comes to algebra. Okay, that makes a big difference. Yes, Hannah?
Would you do equal 60?
You would totally do that, otherwise that's what I was going to get to next. So we're setting ourselves up an equation. That is our expression for our area, but we know that the area is equal to 60. So that's my first step. You would get something for that, even if you went no further. I really don't remember. We'll probably have a look. You would get something for that. Okay, you're not going to get the full marks because obviously we need to end up with what they've got here. Right, we've got several things on the top of this fraction that are like terms, so we can join them together. We've got a 2x plus an x gives us 3x, and we've got a negative 4 and a plus 5, which gives us plus 1. So what I've done is simplify my top line of my thingy. Very complicated word thingy. this divided by 2 multiplied by this gives us 60. Are you all comfortable that I would just multiply both the left side and the right side by 2 to get rid of this fraction?
No.
Essentially, okay, if I want to join them together first, I can say that this is x plus 3 over 1. Yes? So that means I would multiply fractions, it's top times top, bottom times bottom. So I would have 3x plus 1, x plus 3 over 2. You happy with that?
No.
Yeah. So now I can get rid of my divide by 2 by multiplying both sides by 2.
Wait, plus 1x plus 3? Or would it be plus 1 plus Okay.
Good. Right, what am I going to do now? Let's foil. Foil. Yeah, we're expanding our bracket, so we're foiling. However you foil. Joining like terms. And the only difference between mine now and theirs is that theirs equals 0 and mine equals 120. So I'm now going to subtract 120 from both sides, and lo and behold, we've got the same thing now. So when it comes to a show that question, they're going to give you information, you're going to form an equation, and then hopefully, fingers crossed, manipulate that and end up with what they've got. Now, the reason that they would have it as a show that question is that 99% of the time that will be part A, and then part B will be solve that equation, which it was in this case. Now, if you had not been capable, if they had just given you this diagram, told you the area was 60, and then asked you to find the value of x, then you would have been in doo-doo and lost all marks because you hadn't been able to do the first bit. But what they've done is they've given you the answer of 3x squared plus 10x minus 117 equals 0 to now enable you to solve it. And solving quadratic equation, how can we solve a quadratic equation? There's several different methods.
Graphical, the formula.
It's supposed to be not graphical.
It's the formula or.
Yeah, the formula, remember the minus b plus or minus the square root of b squared root blah, 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 yes? Or factorization. Is that what you just said? No. Or you can factorize it if it's easy to factorize. And remember, you've got your calculator does work out that formula for you from the quadratic equation though. Yes? So you remember you just have to stick the 3 numbers in. So you write the equation values and then just stick the 3 numbers in, your calculator does it for you. And if you've been asked, I can't remember what, I did cut this off because most people were fine with it. I think it asked you what solve the value of x in this case. So you're always going to get 2 solutions when you solve a quadratic. Now lots of people were ignoring the negative one completely and not even writing it down. You should write the negative value down, but then make note that you're ignoring it because it can't be negative. Okay, so don't just ignore it, write it down. Yes? Alright, so having the negative part means that if you were just asked to solve this equation, you must give both answers. Both answers give you the correct value. Okay, both our answers are acceptable. Only when it is a practical situation do you then decide whether both are an option. Okay? So if you were just asked to solve this, you must give both solutions. If you're asked to identify a value of x, then you would then say you can't have a negative value. Now sometimes both are going to be fine, but most of the time one of them is not. Most of the
How do we
time.
tell which to certain one?
You look to see if it makes sense. Because here, our value of x determines our length of it.
Okay.
Okay?
Wait.
So if your value of x had been -1, you could add 5 to it, you could add 3 to it, and get a positive number. If you stuck it in there, would you get a positive number? So would you get a positive number for all of those? And so then it could be fine. Okay, so it's not necessarily that just because it's negative it can't be. It's if you substitute it in here, would it still be okay?
So, what were the answers to that one?
I don't remember. I can find that out for you.
4.80 and minus 8.13.
Oh yeah, some people's rounding was rubbish.
No.
That's a bit harsh, isn't it? That's rubbish. It's incorrect.
Yeah.
Yeah, so you've got to remember when you're rounding, if you're rounding to three significant figures, you must look at the fourth one and decide is that a 5 or more, and if so, it bumps it up, remember? Okay, so it was 4.8 though. Well done.
80.
80. 80. I know, it's just random.
I think I just wrote it.
Alright, okay, now, I've just talked to you about how to do a show that question. So I'm going to leave you for a few minutes because this is another show that question. Please don't look at your assignments,
But,
okay? Hide your assignment from you
what about that one?
because even if you did it all on your own, I want you to remember how to do it. It's the process that's important, not necessarily the answer. So have a look at it. It says, these are your measurements. You're talking about the area of this hexagon. Okay? So you think to yourself, how do you find the area of a hexagon? Or how do you find the area of a shape like this? This is like going back to if I just gave you this shape, how would you find the area of it?
If I was to cut it into 2 squares, how much longer would that make the process?
No, that is exactly what you have to do. I would cut it up.
Oh.
Okay, so to find shapes like this, you cut it up into familiar things. So either down here or down across here.
Which one are you going to use?
I'll use whichever. Most people did this one. Alright, just so we can look back at this at some other time and remember what we did. I think I've seen everyone's got this. So we need an expression for this green bit here. We can see that this length, it would be this whole length, the 4x minus 3, subtract the 4. Now you need to make sure that you're doing this before you start doing any multiplication, because that's when you start to fall into issues if you haven't. So we join our like terms and get 4x minus 7. So now I can find this area here. So I've got the 4x minus 3, no, totally not 3, 7 now. So we've got 4x minus 7 multiplied by x plus 1. And this area here is just going to be 4 multiplied by 3x, which is usually 12x. So we're going to add on 12x, and that's going to give us 40. So you're going to FOIL, join like terms, rearrange, fold your uncle, you end up with 4x squared plus 9x minus 7. Wait.
So I get that, but like, for the 4x minus 7, like, why would you only take away 4 from the, I mean, like, why would you do anything to the 4x part? You only did
Because they're not like terms. Oh, what did I do there?
Oh, you're right.
Really?
No, I'm not always going to be, but I'm kind of, oh, shiver me timbers. I won't always be right, but most of the time I will. Okay, good. And that's it. That one, yes? What? Oh, next question. Oh, yes, this one. Now, factorize. What does factorize mean?
I don't know.
No. What does factorize mean? Put it into brackets, okay? So, when we're factorizing something, we need to have brackets. Now, you might say, well, it's already got brackets, I'm good to go. No. Some of you did some beautiful expansion, some joining like terms, then factorizing, your heads were probably going blah, 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 because there was just so much going on.
Yes.
Okay? ideally, she says now, you should be looking at this saying, oh look, there's something squared, subtract something else squared, which means it's the difference of two squares. Okay? So when you have a squared minus b squared, if we were to factorize that expression, what would we have in our two brackets? A
Plus
b and a minus b, yes? So it's easy to say now,
but it wasn't.
but it wasn't when you were doing it. And bless your little hearts, you must have spent hours doing some of that expansion because there was a lot going on. Oh, Mr. Chemo did it. Nice. Thanks, Mr. Alright, so in my two brackets then, I'm going to have A, which in this case is a fancy pants thing, it's a big thing. It's 12x minus y, plus 4x minus 3y. And in my other bracket, I will have 12x minus y, subtract. Now notice I'm actually going to put a bracket around this one, because I need to subtract everything. When I am adding it, I don't need to worry about my brackets. But when I'm subtracting, it makes a big difference. Okay? Now, first things first, is everyone comfortable where I got these things from?
I am.
So, this is something squared, subtract something else squared. Yes, you see that? That's the difference of two squares. So if I had a squared minus b squared, I would factorize it. I would have a plus b and a minus b. That's how we factorize the difference of two squares. Yeah? So all I've done is I've identified that this is a, essentially, putting that there, plus b and a minus b. Okay.
And what if there was a plus sign in between?
You wouldn't be able to do it. It's only because this is subtract. Yeah. Difference indicates subtract.
So that's how we know if it's a difference between.
If it's something squared, subtract something else squared, or can be written like that. Yeah. Okay. Right. So, yes.
Sorry. Okay, now I get it. I get it.
You crack me up.
Yeah.
Just by putting your hand up, you seem to assimilate what's going on. I say nothing, and suddenly you're good. Right?
Yeah.
Or do you just get a bit awkward because everyone now wait for you to ask?
No, I get it now.
Alright. Okay, so in my big bracket here on the left, I can join like terms straight away. So I've got 12x here and 4x. That gives me 16x. I've got negative y and a negative 3y, which gives me negative 4y. Okay, so that one's done. Well, partially. This one here, remember my negative sign affects everything inside here, so I've got to do some expansion before I do my joining like terms. So I've got negative 4x plus 3y. Okay? Everyone comfortable with that?
Hold on.
No, I'm holding on.
2 seconds.
Alright, so this one's still good. Well, I'll do something in a minute. Joining like terms now, I've got 12x subtract 4x, which gives me 8x. I've got negative y plus 3y, which gives me plus 2y. Now, some of you left yours like that. So you were very excited by the fact that you've done that. Unfortunately, you haven't completely factorized it. Because you've still got things that are common. So what we're going to do is say, okay, well let's just look at this side. What's common to 16x and minus 4y? 4. So I'm going to factorize that and bring out this. Oh, that's no longer 16. So this is going to be 4 brackets 4x minus y. You happy with that? Yeah? And then I'm going to do a similar thing now here with this bracket. What's common to this bracket?
2.
2 bracket 4x plus y.
Oh, and you look for like the lowest common multiple.
you're going to look for the highest common factor. Okay, so the highest number that goes into 16 and 4, and the highest number that goes into 8 and 2.
Yeah.
Yep. Now, we knew that these brackets were being multiplied by each other, yes? Which means that these things are all being multiplied by each other.
No.
Does the order of multiplication matter?
No.
Which means that I can say, well, look, if I've got a 4 here and I'm multiplying by a 2 here, I can say that that's 8. Right?
Why
So I can write this separately. Yeah? And then I know, because I've got two big numbers, I can actually join them together and make an actual number. So because I know these things are all being multiplied, I would say that this is 4 multiplied by 2, which is 8. And then just write my two other brackets. Oh, I've got hands shooting out back there.
Why did you just spoil it?
Because if I foil it, I've taken it out of my brackets. I want factorising means to put into brackets. Now, you could have foiled it, and you'd have got big numbers, and you'd be looking for the difference of 2 squares again, but you're just making your life a little bit woo-hoo. It's way easier. So if you are joyful with expanding brackets, simplifying and refactorizing, go do that method. That's totally up to you. Eva, do you have a question? Someone else had their hand up over there. Is there an actual question this time? Because these two do seem to have a question.
Yeah, I do. Yes, I thought it was. Did we do the thing where we make those two and put them into a bracket?
We make those two.
Like the 4 and the 2, and we put that into a bracket.
the middle term.
And then we have the.
Do you mean splitting the middle term?
Yeah, probably.
That would be something like if we had 4x squared plus 3x plus 7. When this is a number, not just an x.
Okay.
Hannah.
Okay.
There's a big roll of it just there. Is it pure maths?
No, I just.
Oh, I got it there.
Thank you.
Oh, you're a penny box.
Yeah.
Right, okay, so that's that version of that one. Right, okay. This one here, we've got 4 bracket x minus 5 squared plus 3 bracket x minus 5. Now, it may help to say, okay, well, what does this mean? It means that I've got this. Do you agree with that? So this 4 bracket x minus 5 squared means that I've got that. Now, again, you could expand using FOIL, arrange, bring it back together and refactorize. But ideally, it should be quicker to notice that what do you have that's common in this term and this term? That is the whole thing.
So you just cross it out.
So that's, no, you don't just cross it out. That's common, okay? So that goes to the front in its own little bracket. And then whatever is left goes in the other bracket. So I've got 4 bracket x minus 5 plus 3.
Why can't we just cross it out?
Okay, so I'm just going to have a little look at that, make sure that you're comfortable with what I've done. So my bracket was common, so that went to the front. Then whatever is left, it's just the rules of factorizing, whatever is left, it goes inside another bracket. Okay? But now I can expand and simplify what's in my black bracket. So my red one stays as is. And I'm going to expand this one. So I've got 4x minus 20 plus 3. Which is 4x